Moving on, explaining rates. Now, how are we going to explain all of the rates that we have talked about? कितने factors होते हैं affecting the rate of reaction? We have number one, catalyst. Number two, temperature. Number three, surface area. And number four, we have the concentration. Increasing the number of successful collisions means that a greater proportion of reactant particles collide to form product. Now, our main mission is to increase the number of successful collisions. Now, I can do that by increasing the surface area as well. I can increase the collisions by increasing the temperature as well, ताकि उससे kinetic energy increase होगी, particles would move faster. Or I can also do that by adding a catalyst, or I can also do it by increasing the concentration. Now we have previously seen that the following factors influence the rate of reaction: increasing the concentration, increasing the temperature, increasing the surface area, and the use of catalyst. So we can use the collision theory to explain why these factors influence the rate of reaction. The diagram shows a higher concentration of particles in B, which means that there are more particles present in the same volume than A. So the number of collision between reactant particles is increased, causing an increased rate of reaction. So what is going to happen? Over here, the particles are in lesser concentration, but the moment I have increased the concentration, the number of particles, NOP, the number of particles have also increased, which is going to also increase the collision. So ये आपके पास question आएगा, and this is a must question. Question क्या होगा? What would be the question? That why does increasing the concentration increase the rate of reaction? We know that when I increase the concentration, rate of reaction will be increased. But why? What's the reason behind that? This is the reason. Okay, by increasing the concentration, you are increasing the number of particles and the number of collisions as well. So increasing the concentration of a solution will increase the rate of reaction. This is because there will be more reactant particles in a given volume, allowing more frequent and successful collisions per second. If you double the number of particles, you will also find double the number of collisions per second, and number of collisions is proportional to the number of particles present. Temperature से क्या effect पड़ता है? The second factor, temperature. An increase in temperature would do what? It would increase the kinetic energy. When kinetic energy is the velocity or the speed of the particles would increase. When their speed increases, the number of collisions will also increase, which means that more reactants would be converted into products, and that means that yes, the rate of reaction will also increase. Increasing the temperature, the rate of reaction will increase. This is because the particles will have more kinetic energy than it is required activation energy. Therefore, there will be more frequent and successful collisions per second, increasing the rate of reaction. The effect of temperature on collisions is not so straightforward as concentration or surface area. A small increase in temperature causes a large increase in rate. And for aqueous and gaseous system, a rough rule of thumb is that every 10-degree increase in temperature, the rate of reaction always doubles. The third factor, which is the surface area of the solid, याद रखो, when I increase, अब question आता है, why does increasing the surface area increase the rate? उसका reason ये है that when you increase the surface area, what happens? More particles are now exposed, ठीक है, more reactants will be converted into products and hence the rate of reaction will increase. आपकी number of effective collisions increase हो जाती है. There's one thing known as collision, which is just collision. Effective collision mean that the collision also produce products. And with an increase in the surface area of a solid reactant, the rate of reaction will increase. This is because more surface area of particles will be exposed to the other reactant, producing a higher number of collisions per second. And if you double the surface area, you will double the number of collisions per second as well. Now the question arises, how do these catalysts work? Catalysts तो वही substances that speed up the reaction. Catalysts are substances which speed up the rate of reaction without themselves being altered or consumed in the reaction. They just speed up the reaction. They themselves don't participate. The mass of the catalyst at the beginning and at the end of the reaction would always be the same. They do not form part of the equation. An important industrial example is iron, which is used to catalyze the Haber's process for the production of ammonia. Iron beads are used to increase the surface area available for catalysis. Normally, only small amounts of catalyst are needed to have an effect on a reaction. Different processes require different type of catalyst. Haber's process, maybe you have a different catalyst, but they all work on the same principle of providing an alternate route for the reaction to occur. They do this by lowering the activation energy required and hence providing a reaction pathway requiring less energy. Catalysis is a very important branch of chemistry in commercial terms as catalysts increase the rate of reaction, hence they also reduce energy costs. The transition metals are used widely as catalysts. जो transition metals होते हैं जैसे कि iron is used in Haber's process, vanadium is used in contact process, nickel is used in hydrogenation. ये सारे catalyst mostly transition metals होते हैं. So activation energy क्या है? Activation energy is basically the energy needed to start a reaction. पहले देखो, without catalyst or with catalyst. Without catalyst, this much of energy was needed. But the moment I added the catalyst, I only need this much of energy. So you can see the difference between an uncatalyzed reaction and a catalyzed reaction. The diagram shows that a catalyst increases the rate of reaction by providing an alternative pathway which has a lower activation energy, and catalyst provides the reactant another pathway which has a lower activation energy. By lowering the activation energy, a greater proportion of molecules in the reaction mixture have sufficient energy for effective collisions. As a result of this, the rate of the catalyzed reaction is increased compared to the uncatalyzed reaction.